Hello everyone, this is Aditya and today we are going to discuss IAT 2025 mathematics paper. But before that, please do like, share, subscribe my channel and we support this video. Now let's start with the solutions. So let's start with the question number 1. It states how many 3-digit numbers divisible by 5 are there in which no digits are repeated, and these are just our options. Okay. So what is the condition to be divisible by 5, right? So first of all, we have to create a 3-digit number. So to be divisible by 5, it must end with 0 or 5, right? Do you agree or not? Of course, it is the basic condition, right? So this ones place can only have 0 or 5, right? And the hundreds place, it cannot have 0, right? It cannot have 0. Why? Because if it will have 0 in the hundreds place, then it means that this number will become a 2-digit number, right? Of course. Okay. So in this we have to make two cases because we have two numbers, so we have two possibilities, right? So let's assume the first case in which we have 0, right? We have 0 at this place. Okay, so how many ways are there to choose 0? It is only one, right? Okay, now come to this place, third place or hundredth place. So how many numbers are there? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Of course, it's a simple question. Still, I will go to the basics to explain this, right? Okay. So of course, we have already chosen 0. So of course, we can't choose it. And of course, 0 can't come at this place even, right? So we have neglected that. We have just removed that from our possibilities. Now, how many numbers are there? 1, 2, 3 till 9. So we have 9 possibilities for this place. So suppose you choose any number. Suppose you chose 8. Okay. Now how many numbers are left? 1, 2, 3, 4, 5, 6, 7, 8. Right. So for this you have 8 possibilities. So how many total ways are there to choose such kind of number? It is 72. Right. Okay. These are case 1. Right. Okay. Or you can choose a number which ends with 5. Correct. So how many ways are there to choose 5 from this? It is only 1. Right. Okay. Now notice that so in this, let me write it again, this sequence of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Okay. So you have already chosen 5, so you can't choose it now. Now notice that you have only 9 possibilities in this case. And of course, you can't choose 0, right? So how many possibilities you have? 8 possibilities. Anything except 0, right? So suppose you chose 9, for example, right? So now how many numbers are left? 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers are left. So how many possibilities for this case? We have 64, right? So 72 plus 64 will be your answer. So it will be equal to 72 plus 64, which is equal to 136. So our first answer is A, right? This is the correct answer, okay? So now let's move to the second question. But this question was a basic question. If you know fundamentals of counting, you can do it, right? So it was a simple question, right? So this is a second question. Let A be a 3 cross 3 matrix with real entries such that A is this matrix. For how many values of x A will be symmetric? So these are our options 1, 2, 4 and infinity, right? So those who had attempted this problem must have got their answer instantly, right? But those who guessed the answer, they probably must have guessed the answer as infinity, right? Because like it seems to be really unique over here, right? And secondly, you see a cos x, so you can think, yeah, there can be infinite possibilities. But no, it will be option number A, right? Okay, but why? Let's see it. It is very simple, right? So we are given that A is symmetric and that is sufficient to solve this problem, right? What do I mean when I say that A is a symmetric matrix, right? We basically mean that A is equal to A transpose, and it is very simple. A is equal to 4 negative 1 x square plus 1 negative 1 5x 25 cos x and 25 and 7. So what is A transpose? It is this quantity, right? Simple. Okay. Negative 1 5x 25, right? And we have over here uh, x square plus 1 and 25 and 7, right? Correct. Okay, so let's match the elements. If they both are equal, then it means that 4 is equal to 4, that is correct. Minus 1 is equal to minus 1, correct. cos x is equal to x square plus 1. Okay, let's note this for now. Negative 1 is equal to negative 1, correct. 5x is equal to 5x, which means x is equal to x, which means that it can have infinite solutions. But this condition is also there, remember that. Okay, 25 is equal to 25, correct. X square plus 1 is equal to cos x, we have already written that. 25 is equal to 25, 7 is equal to 7. So yeah, it is correct. Now the catch was that notice that x square is always greater than or equal to 0, correct. Of course we are dealing with real numbers since we are given real entries, so x square plus 1 will always be greater than 1, right? Okay, now what is the range of cos x? It lies from negative 1 to 1, right? Okay, so of course if you substitute x is equal to 0, that will the minimum value of this function. It means that cos of 0 is equal to 1, and which is the only solution in this case. So x is equal to 0 is the only solution, so we got only one solution, so option A is correct, right? So it was an easy question according to me, but for many it must have been hard, because many would have faced problem in remembering that x square is greater than 0. But of course if you are preparing, then it is a very basic thing, right? So yeah, I can rate it as like easy to medium, right? And the previous one I can rate it like easy to medium only, right? It was not tough. Okay, so this is our third question. So in this we are given, let n is equal to this expression, which one of the following is true, that n is divisible by 5 or divisible by 9 or by 8 or by 6. So let's say this, and it was a trickier question, I would say. So n is equal to this quantity, r is equal to 1 to infinity negative 1 to the power r 10 cr 2 by 3 raised to power 2 by 3 into 3 to the power 20, right? Okay, correct. So let me rearrange this. So notice that 2 by 3 to the power 2r can be written as 4 by 3 to the power r, correct? I mean 4 by 9, right? And 3 to the power 20 can be written as 9 to the power 10, right? Now notice that when you multiply them, you will get 4 to the power r into 9 to the power 10 minus r, right? Correct. What I did, 10, 9 to the power 10 divided 9 to the power r into 4 to the power, right? I just distributed this power, right? And I just use the properties of exponents, right? This, right? So we get this expression that n is equal to this sum 1 to 10 of the quantity 10 cr negative 1 to the power r into the quantity 9 to the power 10 minus r into 4 to the power r. Now did you notice one thing? It is very simple. It is equal to 9 minus 4 to the power 10, right? Isn't it really simple, right? Okay, so it basically means that 5 to the power 10, right? So which is divisible by what? Divisible by what? 5, right? Of course this is divisible by 5. You remember a plus b to the power n is equal to summation n is equal to 1 to infinity ncr I is equal to, sorry, I is equal to 1 to n r, right? Of the quantity it goes from 0, sorry, of the quantity a to the power n minus r into b to the power r, right? Something like that. Okay, so this is the same expression which I wrote over here, right? So from this you get that it is divisible by 5. So there was a bit of manipulation required over here, so I can rate it as medium question, right? But it was also on the easier side, I would say, but still it required some manipulation, so I would rate it as medium, right? So let's move to the next question. So this is our fourth question. Let f be a function from real to real with a function given by fx is equal to cos of tan inverse x. Then which of the following is true? That f is decreasing for x greater than 0, f is decreasing for x less than 0, f is decreasing on real number, or f is decreasing on negative 1 to n. I mean negative 1 to 1, right? So let's see it how we'll solve this problem. So notice that first of all you have to convert this from a trig function to an algebraic function, because you notice an inverse function in this case and a normal trig function, so it means that they can nullify each other, right? Okay, so you get cos of tan inverse x, it can be written as 1 upon sec of tan inverse x, correct? And it can be written as 1 upon square root 1 plus tan square tan inverse of x. So this is our equation. So this is equal to 1 upon 1 plus x square, right? Correct. So far so good. Okay. Now notice that, just imagine, right? Either you can imagine or you can take the derivative test. So first of all, let's take the derivative test so it will become easier for you. So fx is equal to 1 upon root 1 plus x square. So what is f dash of x? It is simply equal to this quantity. It will become negative 1 by 2 root 1 plus x square, right? Whole to the power 3 into the derivative of this quantity, it will become 2x. So it will be negative x by root 1 plus x square whole to the 3, right? Right, correct. Okay, so okay, so f dash x is equal to negative x by the quantity 1 plus x square 3 by 2. And if we have to check for the decreasing function, so first of all let's see that for what value of x is it increasing, right? So let's take it greater than 0, right? Okay, so in that case x is less than 0. So for x less than 0, this function is an increasing function, right? Strictly increasing, I would say. And if we take f dash of x negative, which means we are checking for the negative derivative, which means that we are checking for whether the function is decreasing or not, right? So it will be negative x by 1 plus x square 3 by 2 less than 0, which implies that x is greater than 0. So the function is increasing for x less than 0 and is decreasing for x greater than 0. So this will be our answer, right? It was a bit manipulative question. Now what can be a second approach? It is a logical approach, I would say. That suppose if you are going from a negative number, what can be the minimum value of this function? I mean the maximum value of this function. It can be when you put x is equal to 0. So it will look something like this at 1, right? It is maximum. So if you are going from a negative integer or a negative value to 0, what you will get? You will get something like this, right? You will get something like this. Okay, correct. Okay, and when you are going from x is equal to 0 to a positive integer, it will again decrease, right? And it means that in this region for x less than 0, it was an increasing function, right? And for this domain it should be a decreasing function. The graph can vary. I don't know what is the graph of this function right now, but this can be approached, right, to check for it. Okay, so now let's move to the next question. So this is our next question. Let A be this set, then which of the following is correct? A is equal to this. These are the options. So now notice one thing in this question. The student who just saw these braces and they came to the conclusion that let's mark this option, they must have got the marks, right? Okay. But yeah, that was a straightforward question, right? Here what could have been a trap is that suppose when you solve this uh, determinant and suppose you ended up getting x from negative 3 to suppose let's assume it like 2, right? Okay, so in that case this would have been the correct answer, right? Okay, why? Because of course it includes negative 2, right? Correct. So it means that here they could have built a trap for students, but they did not do that. They wanted to make this question easy, so I would of course rate this question super easy, or maybe easy, right? Because it was a simple question and not super easy. We can say it like it was easy question because it involved the opening of the determinant, but still I would rate it as a basic question, a easy question. And previous one I would rate like easy to medium. So of course this is not the answer. The answer will be option A, and you must have calculated also. Let's solve it. So what is the determinant of this expression? 3x minus 1 into 5 minus minus plus 4. It lies like this, and it is very simple. Like it is from 11th standard what you are studying. It is simple wavy curve, or we don't need that even. It is very simple. It is negative 35 3x minus 1 multiplied by 5 25, right? Divided by 5, negative 7, 3x minus 1, 5, right? Minus 6, 3x, and 6, negative 2x, 2, right? Option A, right? Simple. So let's move to the next question. So this is our next question. In this we are given that z1, z2, z3 are complex numbers, and we are given this relation that 2 is equal to mod of 2z1 is equal to mod of z2 minus 1 is equal to mod of z3 plus 1 is equal to mod of 1 upon z1 plus mod of 1 plus 1 upon z2 minus 1 plus 1 upon z3 plus 1, right? Okay, this is the question, and we have to find this expression 4z1 plus z2 plus z3. So this can be done using two methods, like you can assume a value for z1, z2 and z3 and then solve, or you can directly apply the formula. So first of all, let's do it by the simple method, right? Okay, so notice that suppose if you assume z1 as equal to 1 plus 0i, let's assume it is also a complex number, and z2 as suppose you can assume it suppose 3 plus 0i, and suppose z3 is equal to, suppose you can assume it like that, you can assume it as 1, right? Okay, 1 plus 0i, right? Why I'm writing cap 0i, right? Okay, so now notice that why I choose these numbers only. Let's see over here. We are having 1 upon z1 plus 1 upon z2 minus, I mean z2 minus 1 plus 1 upon z3 plus 1, right? Okay, now from this I get mod of z1 is equal to 1. So from that I thought that let's substitute z1 as 1 directly instead of mod of z1. So I substitute 1 over here just for example. Then I thought that let's substitute over here 1 by 2. Let's do it, plus 1 by 2, right? What will it sum? It will be equal to 1. So 1 plus 1 is equal to 2. So it is satisfying this condition, right? What I've done is that I just thought that instead of z1 I can put 1, and instead of this I can put 1 by 2 plus 1 by 2, right? This is a basic approach that you would think first of all in such kind of problems, right? Okay, now what can be done is that just verify that whether these two numbers are satisfying or not. So let's see. If this is equal to 2, then z2 minus 1 will be equal to 2, and z3 minus z3 plus 1 must be equal to, so z3 is equal to 3, and z2 is equal to 3 and z3 is equal to 1, right? So z2 is equal to 3 and z3 is equal to 1, right? And z1 is equal to 1. This is my assumption, and I changed whole problem from complex number to a purely real number. Of course, a real number I can say instead of saying purely real number, right? Because they both mean same, right? So of course now this problem is very simple. Let's substitute the value. So mod of 2 times 1 is 2, correct? And when you substitute 3 minus 1, it is 2 again, and when you substitute 1 you get 1 plus 1 as 2 again, right? So you basically checked for these values that yeah, it is correct. Okay, now substitute in the problem. So 4 times 1 plus 3 times 1, right? Plus 1 times 1, it will be equal to 8. Simple, right? This was a basic approach, right, which you can apply if you can imagine, right, that yeah, let's substitute 2 over here and 2 over here, right, to get the answer as 2, right? But yeah, it is not a practical approach many times, because sometimes it does not apply. Suppose sometimes it happens that to assume these two numbers, it may be like these numbers are very big or something like that. So in that case you can't assume that numbers. So for that I'm going to tell you all a basic approach or a general approach to such kind of problems. So let's see. Now let's do it by second method. We are given that mod of 2z1 is equal to, which means that mod z1 is equal to 1. So mod z1 is equal to 1, which means that mod z1 whole square will be equal to 1, correct? Which means that z1 into the complex conjugate of z1 will be equal to 1, which means that 1 upon z1 is equal to z1 bar, right? Okay, fine. Okay, now notice mod of z2 minus 1 can be is equal to 2. So it means that mod of z2 minus 1 whole square is equal to 4, which means that z2 minus 1 into the complex conjugate of z2 minus this is equal to 4, which implies that 1 upon z2 minus 1 is equal to, or 4 upon z2 minus z1. Notice I brought this over here in the denominator, right? Is equal to z2 minus 1, right? Notice I distributed this conjugate, right? The conjugate of 1 is 1 itself, right? Okay. Similarly, z3 plus 1 is equal to 2, which implies that similarly 4 upon z3 plus 1 is equal to z3 plus this quantity, right? Okay. Now let's substitute this over here, right? So what you get? You get what is 1 upon, let me write the expression so that you don't get confused. Z2 minus 1 plus Z3 plus 1 is equal to this quantity, Z1 plus Z2 minus 1, or yeah, I can write it like this, 1 upon 4, right? And this also, this upon 4. So it will be Z2 bar by 4 plus what? Z3 bar plus 1 by 4, right? Because we are ultimately substituting the value of 1 upon Z3 plus 1, 1 upon Z2 minus 1 and 1 upon Z1. So that is why I brought 4 over here, right? Okay. Now just solve it. Z1 bar plus minus 1 plus 1, it gets cancelled. So you're left with Z2 bar plus Z3 bar whole divided by 4, and it is equal to what? It is equal to 2, correct? Since we are originally given that here this value is equal to 2, right? Are you understanding or not? Earlier it was that this expression is equal to this expression, so I use this expression to go from this to this, right? Fine, correct? Yeah. So you get let me write it over here. So from this we get mod of 4z1 bar plus z2 bar plus z3 bar by 4 is equal to 2. So 4z1 plus z2 plus z3 bar is equal to 8. Now in modulus we can write it like this. You know this property, correct? This whole will become like this. So I can write this question as easy, not easy, from medium to slight difficult, because many of you must have got confused over here or something like that, or many of you must have tried substituting values, but many of you must have not got the values. That can also be taken in consideration. So I can say it can be from medium to slight difficult, right? Okay, so let's move to the next question. So this is our next question. Let f belong to R is defined as fx is equal to this quantity, then which is true. Every non-zero integer is the point of discontinuity of f. Okay, f is continuous on real number. Every integer is point of discontinuity, and d point f is continuous everywhere except x is equal to 0 plus minus root 3. Okay, let's see, 0 or plus minus root 3. So let's see. Okay, so fx is equal to x cube minus 3x modulus function gif of x. You know what is meant by gif? Suppose gif of 3.4, it will give the greatest integer less than or equal to this number, so it will be equal to 3, right? It is also called GIF, or greatest integer function. Suppose 2.9, it will be equal to 2. Negative 3.4, it will be equal to negative 4. Since negative 4 is less than this number, right? So we have to go to the least number, right? I mean so we have to go to the previous integer, right? Basically. Okay. And yeah, gif of 2.0 is equal to 2, right? Okay. So now notice that fx is equal to this. So let's plot x cube minus 3x for now, right? Okay. Whatever be it, it will be somewhat like this, right? Correct? Something like this. Okay. It will cut at root 3, negative root 3 and 0. Why? Because x cube minus 3x is equal to 0. So x into x square minus 3 is equal to 0. X is equal to 0, or x is equal to plus minus root 3, right? These are positive root 3 and these are negative root 3. Okay. Now when you apply mod, then this term will come upwards, right? It will become something like this. Okay, correct? Fine. Okay, because it was going like this, so it got reflected, right? Okay, now when you are multiplying by gif of x, so notice one thing, let me raise this. Yeah, so when you are going from suppose 0 to 1, suppose from this is our, so let's assume 1 somewhere, suppose over here, right? So corresponding to it, it will have some value, right? But we don't need to worry about that. So if you are evaluating from 0, from x belonging to 0 to 1, in that case gif of x is equal to 0. So this whole expression from 1 to this, it will become what? It will become 0, correct? Okay, 0 included, right? Over here, right? And this is excluded. So notice that we got first discontinuity over here, right? Correct? Okay, which means that the function is discontinuous at this point, right? Now let's check for negative one, I mean from x belonging to, so in that case when you take gif of suppose whatever number, suppose you are going from here to suppose negative 1 over here. Okay, so what will be the value at this instant? Well, let's see. So it will be negative of some quantity, right? Okay, because gif of this quantity will be equal to negative 1, correct? So this graph will be reflected over here, so it will look something like this, correct? Okay, fine. Why? Because then this expression will become from x cube minus 3x mod gif x, it will become negative of x cube minus 3x, right? Correct. So it will go like this, and it will be discontinuous, and of course at this point also it will get reflected, and it will go something somewhat like this. Okay, something like this. Okay, so notice that this function is continuous at x is equal to 0, right? You can notice this. Okay, because you can see from here also, right, that at x is equal to 0 this function is continuous, but rest all the points it is discontinuous at integral points, right? So it means that option A is correct, right? Okay, so now let's move to the next question. So this is our next question. We are given let L be the tangent line to this ellipse at this point. What is the equation of line perpendicular to L passing through 2 comma 0? So at first it seems to be a question of conic section, but when you analyze it a bit, then you will realize that it is a question from AOD. It can be solved easier using AOD, right? I would say it can solve using conic section also. There's no harm in that, but it is much easier to solve it using AOD, right? So I'll be preferring AOD method over here, right? Okay, so you are given the ellipse as this 16y square is equal to 4. So what I'm going to do is that I will take the derivative. Wait, let me take. So suppose this is your ellipse, right? And this is the point 1 comma root 3 by 4. I'm not drawing the complete ellipse because it is not required. And suppose it passes like this. Okay, it should pass like this. Wait, it passes like this. Okay, now notice that whatever will be the slope of this tangent will be the slope at this point, or will be the derivative at this point, right? Because they both are in the same direction, right? Okay, so which means that x square, I will take the derivative, so 2x plus 32y is equal to 0, right? Which means that of course dy by dx, this is the slope for the derivative at that point. Okay, so it means that dy by dx is equal to negative x by 16y, correct? Okay, now let's see what's given in, and yeah, we are evaluating it at 1 comma. Okay, this is for a general point, right? We got this for a general point, and it will be equal to m1 when dy by dx is evaluated at 1 comma root 3 by 4, right? Okay, so I'm not substituting the value because there's something else in the question. What is the equation of line perpendicular to L and passing through 2 comma 0? So we are given that this line is perpendicular to L. So it means that if it is perpendicular, then suppose its slope is m2, then m1 into m2 must be equal to negative 1, correct? So m2 is equal to negative 1 by m1. You substitute this value, you will get negative 1 upon dy by dx evaluated at 1 comma root 3 by 4. So you get negative 1 by negative x into 16y. So you get 16y by x evaluated at this value. So I will just substitute the values. I will get 16 root 3 by 4 by 1. So we get 4 root 3 by 1, right? So m2 is equal to this value. Okay. Now either you apply point slope form or you just apply the general form that y is equal to mx plus c, and from this you substitute the value as 0 is equal to 2m plus c. From this you get c is equal to negative 2m, and then you substitute y is equal to mx plus minus 2m. So you get m times x minus 2, 4 root 2, 4 root 3 x minus 2. Either from this you get the answer, or you just apply y minus y naught, y1 you can say, because we already used y naught for this, x naught comma y naught, right, is equal to m into x minus x naught, right? Okay, x1, sorry, x1 sorry. Okay, so y minus 0 is equal to 4 root 3 x minus 2, right? So from this we are getting this answer, right? Now notice that I did not put the options over here. Why? Because to make the question more challenging for you all, right? Because if I would have given the option, you would try to think like that. So I did not give the options, right? So from this I can say that this is our answer, and I would rate this question as medium question and the previous one as from medium to difficult, I can say, right? Now let's move to the next question, right? So this is our next question. Let a vector and b vector be two vectors such that the magnitude of a vector plus b vector is equal to 15, and a vector cross 3i cap minus 4j, this expression. Then find the value of this expression, and these are our options, right? So let's solve it. So a vector cross 3i cap minus 4j cap plus 5k cap is equal to 3i cap minus 4j cap plus 5k cap cross b vector. Now let's bring this over here. So you get a cross 3i minus 4j cap plus 5k cap minus 3i cap minus 4j cap plus 5k cap cross b vector is equal to 0, right? Okay, now wait, I know that you all must be confused that why I'm doing like this. Okay, so what is my approach over here? That since I saw that it is a cross product and this is also a cross product, and the biggest hint which I got is that I saw that the second and the first vector in these two equality, they both are equal, right? And which means that there's some hint in this that we can take something common in this, right? That is the biggest hint. And now notice that x vector cross y vector is equal to negative of y vector cross x vector, correct? Right? Which means that I can write it like this, right? 3i cap minus 4j cap plus 5k cap minus minus will become plus b vector cross 3i cap minus 4j cap plus 5k cap, right, is equal to 0. Now since they are at same positions, so I can take it as common, right, from right side, right? So a vector plus b vector cross 3i cap minus 4j cap plus 5k cap is equal to 0, right? Now why I taken common it from the right side, why not from the left side? Because if you know, a vector cross b vector plus c vector cross b vector is equal to a vector plus c vector cross b vector, and b vector cross a vector plus b vector cross c vector is equal to b vector cross a plus c vector, right? Means whatever place you see, if they both are at same place and they both are equal, just take common from that side only. Okay, that is the reason. Of course I did not roll the reason, that is the method I am saying. If you want to know the reason, I will make a video on it, but for now let's stick to the questions only, right? Okay, so a is equal to this. So from this it means that since you know that magnitude of this vector is 15 and magnitude of this vector is also 15, right? Not 15, it will be something else, but still uh, this is non-zero and this is also non-zero, right? Which means that the angle between them must be equal to 0, right? Why? If I take mod on both sides, it means that mod of this expression into mod of this expression, suppose I name it as a and this b vector, so mod of a vector mod of b vector into sine theta must be equal to 0, right? If I am taking the mod, so it means that either of these quantities must be equal to 0. Since a vector is not equal to 0, we know this. B vector, it will be equal to root 3, I mean root 9 plus, I mean square root of 9 3 square plus negative 4 square plus 5 square, which will be equal to root 50, which is equal to 5 root 2. Of course, that is non-zero, right? And which only means that theta is equal to 0, which means that a vector and b vector are parallel to each other, right? Which means that a vector plus b vector is equal to lambda times 3 I cap minus 4j cap plus 5k cap, right? You know why I am doing like this? Because this is our a vector and this is a b vector, okay? And suppose this is and this is our this vector 3 I cap minus 4j cap plus 5k cap, so they both are actually parallel to each other, right? Okay, so it means that if these two are parallel, then we know the condition that their ratio must be equal, right? So it means that it should be equal to lambda times this quantity. Now how do I solve for lambda? Well, you are given one condition over here. It is very simple. So you basically get lambda times 3I minus 4j plus 5k mod is equal to 15, which means that square root 9 lambda square plus 16 lambda square plus 50 plus 25 lambda square is equal to 15, right? Which means that when you solve it, it will be equal to 50 lambda square, so you get 5 root 2 lambda is equal to 15, so you get lambda is equal to root 3 by 2, right? Correct? Okay, so from this we get lambda is equal to root 3 by 2. Let me raise this. So we got a plus b is equal to this expression, right? Okay, now let's solve it. Okay, so you get root 3 by 2 into 3 I cap minus 4j cap plus 5k cap dot 2 I cap plus 3j cap plus k cap, right? And root 3 can be taken as common, so you get 6 minus 12 plus 5, and you get root 3 by 2 negative 1, so it is equal to root 3 by 2. Of course, you are asked the modulus over here, the magnitude, so of course you will get this quantity, right? Now why it happened, let me tell you. I hope so that you know dot product. If you don't know, let me tell you. Suppose a vector is equal to ax I cap plus b plus ay j cap plus ak az k cap. Suppose b vector is equal to bx I cap plus by j cap plus bz k cap. Now when you take a dot b, get ax bx plus ay by plus az bz, right? Of course, I'm right now not teaching anything. I'm just solving this paper for you all so that you can understand it. Okay, if you want to learn it, I have already made videos on it. If you want to learn it in more detail, tell me in the comment section. I will make separate videos for it. Okay, so this was the solution of this problem, and of course I would rate this as medium to hard, because I know that many of you must not be knowing this property or something like that. Okay, so that is why I can rate it like to be difficult, right? From medium to difficult, I would say. So now let's move to the next question. So this was our question number 10, the derivative of log of sine square x with respect to sine x. I have not given options for this because it is a simple question, so I hope so that you can solve it without options even, right? Okay, so now for this you have to know something called chain rule, right? If you know, then it's fine. If you don't know, let me tell you. Dy by dx can be written as dy by dg, suppose some other function, dot dg by dx. Okay, let me explain what is it. Suppose here we have, suppose we have a function, uh, we can assume it like, suppose let's take sine square x only, right? And we have to find its derivative with respect to, you will be confused, so I'm remove that, derivative of sine square x with respect to, suppose sine x. If I say this, okay, let's take a simple one first of all. So d of, suppose this is equal to y, right? So d of y by dx, it will be equal to dy by dg dot dg multiplied by dg by dx, right? So d of sine square x by dx will be equal to d of sine square x by d of sine x multiplied by d of sine x by dx, right? Correct. Now this is what you are asked, and these two you know how to solve, right? This is equal to 2 sine x into cos x by cos x, so you get this as 2 sine x, right? In this case, similarly, d of natural log of sine square x by dx is equal to d log sine square x by dx dot d, I mean d sine x dot d sine x by dx, right? So what is its derivative? It is very simple, 1 upon sine square x, then you apply the chain rule again, get 2 sine x into cos x is simply equal to this required thing, suppose r into derivative, this is cos x. So notice that one sine and this sine gets cancelled, and this cos x and this cancelled, so you get d required divided d given, oh let me write it like this only, d of log of sine square x by d of sine x is equal to cosec x, right? Correct. Okay, so this is our answer. Okay, and I would rate this question as easy question. If you know the chain rule, then it will be super easy for you. It will be easy. Actually, it is a basic question. So let's move to the next question. So this is a question number 11, and it states that let Sn denote the sum of the first 10 terms of a sequence a1, a2, a3, and so on. If Sn plus 3 minus Sn is equal to this quantity, then find a13 minus a10, right? So let's solve it, right? So Sn plus 3 minus Sn is equal to 13n plus 7, right? And we are asked a13 minus a10. Okay, so I see a a10 over here and a a13 over here. So I get an idea that if I substitute n is equal to 10, then in that case, there's a chance that I will get a13. Why? Because s13 minus s10 will give the terms a13, a12 and a11. Why? Because sn plus 1, suppose sn plus 3 is equal to a1, a2 till an plus a1 plus a1 plus an plus 1 plus an plus 2 plus an plus 3, right? And Sn is equal to a1 till an, right? Which means that this expression is basically equal to Sn. So when you subtract this minus Sn, then it will be equal to this quantity, right? So basically you are going to get an plus 1 plus an plus 2 plus an plus 3 is equal to 13n plus 7. So let's substitute 10. So you will get a11 plus a12 plus a13 is equal to 130 plus 7, right? Or 137. So many would think, yeah, I'm getting 137, this can be answered. So there's chance of mistake over here, right? But now there's a problem, that how do I eliminate a11, a12 and get a10? It is very simple. Just substitute n is equal to, here you substitute n is equal to 10, I mean over here n is equal to 10. Now substitute n is equal to 13, sorry, n is equal to 9, right? So you'll get a of 9 plus 1, 10, a plus 11 plus a plus 12 is equal to 13 into 9 plus 7. It will be equal to what, right? Let's see. So it will be equal to, we don't need to even calculate it, right? Why? Because 130, it is simply equal to what? 130 into 10 plus 7, sorry, 13 into 10, and this is equal to 13 into 9 plus 7, right? Just take the difference, you will get a13 minus a10, right, is equal to 13, taken as common, 10 minus 9, 7 and 7 gets cancelled, you get 13. This is the answer, right? It is very simple. This and this will get cancelled with these, and here you will get a negative sign, here also, and you will get this. So I would rate this question as medium question, right? Because here there was a double substitution of n is equal to 10 and n is equal to 9. So yeah, it can be treated as a medium question, right? Now let's move to the next question. So this is our next question. 5 fair coins are tossed independently. What is the probability that at least 2 heads appear, right? And these are our options. Okay, so let's see it, right? It's also a basic question of probability. So we have 5 fair coins, which means that each coin will have 2 possibilities, right? And since we have 5 coins, so 2 2 2, so we have total number of 32 possibilities, 32 possible outcomes, right? So what is the probability that at least 2 heads appear? So in this, either you can apply it like 1 minus p x bar, right, like that, or you can apply directly. How? Let's see. So in how many ways can you get 5 times tail? Of course it's 1. And in how many ways can you get 4 tails and 1 head? It will be 5. Why? Because you can arrange head over here, 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 right, like in 5 ways. And for head and means 2 times head and 3 times tail, it is what? It is equal to 10, right? And then head, tail, it is also 10, right? It is similar to this case for tail, right? Then this, it is also 10, right? You can calculate it, right? Sorry, it will be equal to 5, right? Similar to this case. And what is its probability? It is 1, right? So you add up, you get 10, 32, yeah, 32 possible outcomes we got. And at least 2 heads. So from here we have to start this and this. So 10 plus 10 plus 5 plus 1, it is 26. By 32 you get 13 by 16, right? Option number A. Of course, right now I'm not teaching anything, I'm just solving the papers for you all so that you can understand it a bit. If you want to understand it properly, you should know the concepts a bit, right? Or you can watch my other videos to understand the concepts, right? And if you want to understand the concept in more detail, I can make videos. You just tell me in the comment sections, right? Okay, so let's move to the next question now. So this is our next question. It is stated that there is a function which is going from real to real, and fx is given by this expression. We have to check for 1 1 and onto, right? I've not given the options because it is like obvious that what will be the options, right? So let's solve it. Okay, so now there are two methods to check for 1 1, right? Either you draw the graph of them, right, which is very easy to draw, and if you draw the graph you can directly check for onto also. So it will tell two things. Or you check for x1 and x2, you take two values of the function at x1 and x2 and equate them and check whether you are getting x1 is equal to x2 or you are getting some other relation also, right? For example, if you take 2x and in that if you say 2x1 is equal to x2, right, so in that case x1 is equal to x2, so that is perfectly fine. But if you take for this expression, you will have to solve this equation like x1 square minus 4x1 minus 5 is equal to x2 square minus 4x2 minus 5, and when you solve you get x1 minus x2 into x1 plus x2 minus 4 is equal to 0, right? So from this you can directly see that x1 plus x2 is equal to 4. It means that this is not a 1 1 function, right? Suppose x1 is equal to 3 and x1 is equal to 1. So 3 plus 1 minus 4 is equal to 0, correct? And it satisfies this equation also. I mean, if you substitute x1 as 3 over here, x as 3, you will get what you will get? It will be equal to what? 9 minus 12, it will be equal to minus 3 minus 5 will be equal to minus 8. And you substitute 1, you will get 1 minus 4 minus 5, which is equal to minus 8. So for different values of x, you're getting same value of y, which means the function is not 1 1, right? Okay. But what's the benefit of doing it using a graph? The benefit is that you can directly check for 1 and 1 at the same time. Why? Because see, what is the graph of 2x? It is like this, right? It is at 1, correct, and this is at 2, right? Fine. Okay, now notice that after this function starts. Now what is the value of the function at 1? It is equal to 1 minus, we calculated it is equal to -8. Now we have to check that whether -8 is the minimum value of this expression, this quadratic expression, or not, because we don't know that whether the graph goes like this or this, right? We don't know about it, right? But notice one thing, whatever be the case, let the graph go like this or like this, it don't matter actually. Wait, like this. Why? Because in both of the cases we are just proving that this function is giving the value, because in both of these cases it is still implying that the function is onto and it is not 1 1, right? Because for different values of x we are getting the same value of y, right? So from this we have got that the function is not 1 1 but is onto, right? And of course the graph will be like this. If you want to know why, you check for the vertex minus b by 2a, right? So it will be equal to minus 4 by 2 into 1, which is equal to 2. And what is the value at 2? It is equal to it will be equal to 4 minus 8 minus 5, it is equal to -9, right? This is -9. So -9 is the minimum value of this quadratic expression. It is going like this. Okay, correct. You can check also when you substitute 2, get 4 minus 8, which is equal to -4, minus 5 is equal to -9, right? So this is how the graph looks, and it is not 1 1 but is onto. So it is not 1 1 but is onto. Why? Because its codomain is equal to the range of this function, right? You can clearly see it. It goes till negative infinity and it goes till positive infinity, right? Okay, now let's move to the next question, and I would rate this question as medium, because for this you needed to know the knowledge of graph a bit, not that much still. Okay, so let's move to the next question. So this is our next question, and it is a simple linear differential equation. We are given x is greater than 0, and for x is equal to 1, y is equal to 0. So we have to solve for this equation, right? This differential equation. So let's solve it. So x squared dy by dx plus 9xy is equal to x to the power 4. Now divide by x squared both sides, dy by dx plus 9 by xy is equal to x squared, right? If you remember the format of linear differential equation y, so what is it? It is dy by dx plus py is equal to q. So integrating factor, in this case is equal to e to the power p dx, right? And the equation is integrating factor into y is equal to integral of integrating factor into q dx, right? Like this, and of course a constant, right? I wrote it because I thought that if you don't remember, then you can understand it like this. Okay, so basically p is over here, it is 9 by x, and these are q, right? Okay, so integrating factor is equal to the integral e to the power 9 by x dx. It is equal to integral 9 ln x, and it is equal to x to the power 9, right? Hence x to the power 9 into integrating, this is the integrating factor, into y is integrating factor into the q, that is x square dx plus or arbitrary constant, right? So x to the power 9 y is equal to x to the power 12 by 12. It is x to the power 11. What is the integral of x to the power 11? It is x to the power 12 by 12, right? Plus c, right? Okay. When you substitute y as 0 and x is equal to 1, so you get c is equal to -1 by 12, right? How? We are given that y is equal to 0 and x is equal to 1. So from this you got that 1 into 0 is equal to 1 by 12 plus c. So you get 1 by 12 plus c is equal to 0. So you get c is equal to -1 by 12, right? Okay. So from this you get x to the power 9 into y is equal to x to the power 12 by 12 minus 12. You get this. So 12y is equal to x to the power 3 minus 1 upon x to the power 9, and that's the answer, right? Now let's move to the next question, right? And I would rate this as easy to medium, right? Okay. Let's move to the next question. So this is the last question of mathematics section, and I don't know that why many students told me that the integral 0 to pi x mod cos x was the question that was asked to them in their paper, in many students paper, right? And some told that they got this only. I don't know that why there's so much ambiguity, because in the answer key this question was asked, but I don't know that why many students told that they were asked this question in their question paper, right? I don't know what is the scene over here, but maybe if that is the case, then in that case the answer should be pi over here, right? And for this, let's solve it. Okay, of course, if you know how to solve this one, you can solve easily this one, right? So 0 to pi x mod cos x sin x dx. Now if you know the property a to b of the quantity fx, dx is equal to integral a to b f of a plus b minus x dx, right? If you know this property, then it will be very easy to solve. Suppose this is equal to I, so I will also be equal to 0 to pi minus 0 minus x, right, into the quantity mod of cos of pi plus 0 minus x mod into sine of pi plus 0 minus x dx, correct? Okay, so it is 0 to pi minus x into cos of mod of, what is cos of pi minus x? It is equal to negative cos x, but since we have mod, so it don't matter much, right? Into sine of x itself, right? Okay, sine x, right? This is also equal to I. Just add these two, you will get 2i is equal to the integral 0 to pi of the quantity pi into mod of cos x into sin x dx, right? Okay, now let's solve this expression. Let's solve this integral first of all. Of course, if you solve the integral, you will get the answer. So this quantity cos x sin x dx, right? Now notice that cos x mod cos x is positive, means it will open with positive cos x for x less than pi by 2, and it lies between 0 to, basically if x lies between 0 to pi by 2, it opens with a positive sign, and for negative, I mean for x lying between negative pi by 2, I mean sorry, pi by 2 to pi, it opens with a negative sign, right? Okay, so it is 0 to pi by 2 of the quantity cos x sin x dx, right, minus the quantity pi by 2 to pi of the quantity cos x into sin x dx, right? Correct? Okay, so now you can write it like this: 0 to pi by 2, 1 by 2 sin 2x minus 1 by 2, 0 to pi by 2, sorry, pi by 2 to pi sin 2x dx, right? Okay, so when you solve it, you will get 1 by 2, and it will become negative cos of 2x divided by 2. Limits are from 0 to pi by 2 minus this quantity minus cos of 2x by 2. It goes from pi by 2 to pi, right? Okay, so you basically get what's a brace over here, right? So 1 by 2, this negative sign you can bring to the limits, and you can reverse the limits pi by 2 to 0, right? And this negative and this will become positive, so you can take basically 1 by 2 again common, so you get 1 by 4, right? Over here you will get 1 by 4, because this 1 by 2 and this 1 by 2 when multiplied, they will get 1 by 4, right? And when you substitute cos of 0, what it will become? It will become 1, and 1 minus 1, because cos of 2x, so when you substitute pi by 2, you get cos of pi, which is equal to negative 1. So 1 minus minus 1, it will become 2, right? Plus when you substitute pi, it becomes 0. When you substitute pi by 2, it becomes again pi, so it will be again 2. So it is equal to 4 by 4, which is equal to 1. So basically our I is equal to pi by 2 into 1, which is equal to pi by 2. So in this case, the answer is equal to pi by 2, right? And I would rate this question as medium, maybe, right? If there was really ambiguity in this question, that some students got this question and some got this question, then please do comment in the comment section and let me know, right? So I hope so that this video was helpful for you to understand the question paper, that how the math section was, and I hope so that you understood many new approaches towards these problems. If you did enjoy this video, then please do like, share, subscribe my channel, and we support this video. Bye bye, take care, and all the best.